Okay, so we're going to play around with some sets, and this is called set theory. Basically, we're using some methods that will allow us to, for example, find some common elements between sets or unique elements, across sets. So let's take a look. So I have three sets here. Again, getting back to my painting palette example. Let's say I have a living room palette, and these are the possible colors that I'm going to use in the living room. And then I have the dining room palette with those possible colors, and then a foyer palette. Some of these colors appear in, mahogany, for example, appears in all three sets. The cream color appears in both the living room and dining room sets. And then you have other colors that are just completely unique to that set and only appear once in the whole color scheme. Like, for example, olive only appears once, plum only once. So with that in mind, let's take a look at some of these methods. So there's this intersection method, which will find common elements among sets. So I'm just going to work on the two big sets, the living room and dining room for now. So for the common colors, we're going to call upon the intersection method. We're going to provide living room and dining room sets. Okay, and this intersection method will find the common colors between those sets. So let's print the result that we got. Okay, mahogany and cream appear in both the living room and dining room sets. Okay, easy enough. And then, this is an easy one. There's a union method that will combine all sets. Okay, so let's say I am going off to Menards or Home Depot, and I want these are the colors I've decided on. I want the master list, okay, master list for me to take to the store and buy all the paint. And so I can use union to just combine all of the sets together, okay, and we'll print those results. Okay, so this is the master list. Now note, some of those items, like mahogany and cream, appear in multiple sets, but recall about the set that duplicates are not allowed. So any duplicates are going to be quietly removed by the set. Also, recall that sets are not ordered, so I'm not going to get the original order of any of those sets preserved. It's just going to combine all of the elements across all three sets, remove any dupes, and shuffle all of those items. And maybe you might not want that, in which case the set isn't really not the way to go. But in any case, so that's a union. It'll just combine everything that you give it. Okay, and then we've got a couple more. We have let's see. So we have set difference. Set difference will find elements in one set that are not present in the other. Okay, let's take a look at this. I'm just going to drop the result right into a print statement, kind of killing two birds with one stone here. So I'm going to say find the set difference between the living room and the dining room. And what that is going to do, okay, so I got umber, cadet blue, olive, and navy. So what this does, it gave me what is in the living room that is not in the dining room. Okay, so it's going to find the elements in one set that are not in the other. Because I listed living room first here, it's going to give me what was in the living room palette that is not in the dining room. It's basically giving me everything except mahogany and cream, which are in the dining room palette. Now, let me, just to prove a point here, I'm going to switch the order of these. I'm going to do dining room first, and then living room. Order matters here when you're using this set difference. Okay, so now I just got charcoal, plum, and burgundy, because, again, I'm going to get what's in this case, the dining room, that is not in the living room. So I'm going to get everything except mahogany and cream. So whichever you list first, that becomes like the master set. And those items will be returned as long as they are not in the other set. Okay, so there is that set difference. And then we have one more. It's called symmetric difference. We have the symmetric difference. And this will return elements that appear only once across both sets. This is basically the inverse of the intersection. Remember the intersection method? It found the common elements across both sets, and in this case it found mahogany and cream, okay, because those were common among both sets. But this is like the inverse of that. It's going to find everything that is not common across the sets. The way you call this one is a little different. I'm calling it in the name of the living room set. Living room dot symmetric difference, provide the dining room. It's a little different from the way we called the rest of them. But in any case, I'm getting all of the colors that are unique or appear one time in one set, okay, and are not common among the sets, okay? So I basically got everything in those two sets except the mahogany and cream, which are, you know, the intersection of those sets.